It's simple mathematics. Check it out. I revolve around science.
What are we talking about here?
Okay, I'm going to start my help video on algebra second term, and the goal here is to solve equations. A couple of strategies that we can use. We can use guess and check to try and figure out the missing term, or we can use a balance model. One thing to note is that an equation is simply an expression with an equal sign and an answer. So you got the example here, 2n plus 1, remember from first term looking at algebraic expressions like this. And then you have the equal sign. Okay, so what we're going to try and do is solve and try and figure out what position in the pattern does a value of 43 sit. Okay, now if we refresh our memory, if we were thinking about this pattern, all right, we have position 1, 2, 3, 4, etc., 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 right? Okay, and then if we think that this is the x or the n, sorry, and then our pattern rule is 2n plus 1, the values are going to sit in this column here. So if I plug in a 1 where the n is, right, I'll get 2n plus 1, then I'll get 2 times 1 plus 1, which will give me a value of 2 plus 3, which equals, oh sorry, not 2 plus 3, what am I doing? I was thinking of the answer. Sorry, 2 plus 1 is equal to 3. Okay, so then our first term has a value of 3. Okay, but where is the value of 43? So somewhere in here is this value of 43. Okay, so let's go ahead and figure out how to do that. Well, I can kind of guess. Okay, so I could guess that, okay, 2 times something plus 1 is going to give me 43. Okay, well, I know that 2 times 20 is going to give me 40. So it's got to be close to 40. Okay? So it's got to be, so that 40 gets me close. So it's got to be somewhere close to 20. Okay, so then I need to get something times 2 plus 1 will give me the 3. Okay, so maybe you start to figure this one out, or we have some answer over here. Okay, we have some answers to part of our puzzle over here. So then 2 times 1 gives us 2. Well, if I put those together, all right, so then this equals 42, okay, and then if I add that to the 1, I'm going to get 43. Okay, so by guessing and checking and using my math strategies, I can see that I need to add these together, so I end up with 21. Therefore, n is equal to 21 because of guess and check. Okay, now that works really well for simple numbers, but this value could be a decimal. That value for n could be a decimal, it could be a fraction, it could be a negative number. Okay, so maybe the guess and check is simple for simple equations. However, maybe it doesn't work so well with more complicated equations. So maybe we're going to use the second strategy of balancing the equation. Okay, so I'm just going to go ahead and get rid of some of this stuff here so we can see about balancing the equation. Okay, so when we balance the equation, I want you to think of this. Okay, kind of a balance scale, and we have a triangle with the equal sign in between. And over here we have 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, and then we have, let's do it, 43. So I have 43 objects over here. And then there are two groups of n that I don't know. Two n's. Okay, so this is kind of getting you to think about, okay, I need to put an even amount in each one of these n's. They hold the same value. All right, and then I have the plus 1 over here. Okay, so how many of each of these go in the bag? Okay, well, how do we keep that balanced? Well, first off, in order to just figure out what's inside the bag, I need to get rid of this one that doesn't fit outside the bag. Okay, so how do I get rid of in math? Well, I'm going to take away 1. But if I take away 1 here, I have to, in order to keep that scale balanced, okay, because as it stands right now, if I take away this one, this balance beam is going to start to push down, right? And we want to keep it balanced. So I need to remove 1 here, which will then remove this unbalance, and the scale will stay balanced. Okay? So then, alright, so then I can, alright, so now I'm left with 2 n's in my next picture, and I'm just gonna, okay, and I've got now 42, right? Okay. Just to save time, I'm not going to draw all of those little dots. Okay, so then I need to figure out, okay, so I got 42. I need half to go in one bag and half to go in the other. All right, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. All right, so I've got, I think, half here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, because I've gotten rid of that one. So now I can see that I need remember that this one is gone, 21 in each group. So therefore there are, each n is equal to 21. Okay? So the idea is keeping it balanced. Okay? Now, you can already see that if I have this simple equation of 43, drawing out this particular model is somewhat tedious to draw out 43 dots. Okay? So what we're going to go ahead and do is I'm going to remove that, and we're going to do it mathematically. Okay, so here we have our 2n plus 1 is equal to 43. Okay, now I'm going to keep this scale even. Okay, so this is our scale, and there's our balance. Okay, so this is saying that this side is equal to that side. Okay, or left side is equal to right side. Okay, all right. So now I'm going to go ahead and mathematically do it. So what we did in the picture, if you can remember, is I removed this 1. Okay, well, what does that look like? Well, how do I remove a plus 1 in math? That's right, I subtract 1. Okay, but what I do to one side, I have to do to the other. Therefore, I need to subtract 1 from 43. Okay, now these cancel each other out, And then I'm left with 2n is equal to 42. Okay, I just complete this math on this side. Okay, now what is this saying mathematically? Well, here, this is the same as saying 2 times n, right? Okay, so I need to get rid of that 2. Or you can also think of this as n times 2, right? 2 groups of n. So I need to get rid of this times 2. Well, how did we get rid of the plus 1? If you could look, we did the opposite operation, right? So to get rid of a times 2, I need to do the opposite operation, which would be correct. Divide by 2. So I can divide each side by 2, because what I do to one side, I have to do to the other. Now, you could write this out as 2n divided by 2. Okay, it doesn't matter to me, except for it saves a little bit of space. And then you could do, over here, you could do 42 divided by 2. Doesn't really matter, except for it's going to save space. Okay, now, obviously, these cancel each other out. Okay, so now I'm left with n is equal to 42 divided by 2. Go ahead and use your calculator if you need to. All right, or you can simply go, okay, what's 40 divided by 2? Well, that equals 20. What's 2 divided by 2? Well, that equals 1. Put them together, 21. So therefore, n is equal to 21. Okay, and this is showing each one of these steps, okay, and canceling out on one side and doing the same step on the other side is keeping that scale balanced. Okay, all the way along. Okay, and what the eventual goal is what we call to get this n all by itself. It's sort of like a death sentence or a sentence to isolation in prison. So we're trying to isolate the variable. Okay, so you're going to hear that quite a bit. So isolate the variable. All right, so that's how you balance equations. So let's go ahead now and do a couple on our own.
It's simple mathematics. Check it out.